Good morning. This lesson is for my Trig-Precalc class, but before I get started, I want to say I hope that everyone is doing all right out there. I actually know the title for this lesson. It's Chapter 6, Lesson 5. And I also know our 3 goals for this lesson. Our first goal is going to be to review the side angle side pattern. Our second goal is going to be to create the law of cosines. And our third goal is going to be to find an unknown side length using the law of cosines and to understand where this leads. So let's go ahead and jump right into our first goal here, which is an example of the side angle side pattern. I know a side, I know another side, and I know the included angle. Remember, this pattern does not work for the law of sines, which is sine of angle A over side length A, which I will add to the picture, equal to the sine of angle B divided by the length of side B, which is this guy, and that's equal to sine of angle C divided by length of side C. All right. So let's go ahead and set up the law of sines just to reinforce that it does not work for this. Okay? And I hid my good marker right here, I think. All right, so sine of angle A is going to be sine of 40 degrees. And we're going to divide that by the length of its opposite length, which is just A, we don't know. Sine of angle B is sine of angle B, because I don't have an angle measurement. Sine of angle B, and that's divided by its length, which is 16, its opposite length. And finally, sine of angle C, which I don't know the angle measure for, but I do know its opposite length, and that is 8. All right, so if I cover up the last part of the law of sines, 2 unknowns, angle B and side A. If I cover up the first part of the law of sines, 2 unknowns, angle B and angle C. And if I cover up the middle part of the law of sines, I have 2 unknowns, length A and angle C. I don't have any equations with 1 unknown. So there's no equations with 1 unknown. So again, I want to reinforce the side angle side pattern does not work for law of sines. Okay, let me do that a little bit better. There we go. There we go. All right. So I'm going to go ahead and check off my first goal here. Pattern. Did I spell it right? I don't know. All right. So let's move on to our second goal. And we're going to create the law of sines, or law of cosines. But in order to do that, I need to establish a couple of things. First thing I need to do is I need to find side lengths of a right triangle using cosine of an angle, which I'll call 40, and sine of 40. Okay? I need to get lengths using these trig functions. All right, so I'm going to call this adjacent length x, we'll call this opposite length y, and I am using measurements off of this. I don't know the length of this. I know if I was to draw the whole triangle, that would be 16. I don't know what I'm left with. All right, so I can say that cosine of 40 degrees is equal to the adjacent length divided by the opposite length. Now, if I was to multiply both sides by 8, that would cancel, and the length of this side is 8 times cosine of 40 degrees. Okay, that's that length of that side. So I can either say x or, and this is what we're going to need for our argument here, or I can say 8 times the cosine of 40 degrees. So it's x in length, or it's 8 times cosine of 40, which is actually a number I can calculate. I can calculate this value. So this is actually a number. I know this length now. I can also find the length or the height of my opposite side length, the y height, And so I could say sine of 40 degrees is equal to y divided by 8. And again, just like before, I can multiply both sides by 8. Those cancel, and I get 8 times the sine of 40 degrees. That's equal to that length. So I have lengths that are of a right triangle using cosine of 40 and sine of 40. So this length is my y length, and this length is my x length. Okay? So I wanted to show that. I need to set that up because when I create the law of cosines, I'm going to do that kind of step here. So let me clean this up and add a couple more things that we need, and I'll be back. I'm back. So let's go ahead and continue with our second goal here. Remember, that's to create the law of cosines. I do need to review some tools with you guys so that we, when we see these steps in our creation of the law of cosines, we don't have to focus on this. All right? I would like to just focus on the math of the bigger problem. So the first thing we need to review is that sine squared theta plus cosine squared theta, that's equal to 1. The second thing we need to review is squaring a binomial of this form. So x minus y becomes x minus y times x minus y. And we FOIL this out. Remember, FOIL means firsts, outers, inners, and lasts. FOIL. So x times x is x squared. X times negative y is negative xy. Minus y times x is minus yx. I'll flip it and call it negative xy. And that's not a very good y. And minus y times minus y is plus y squared. I have two of these, so I get x squared minus 2xy plus y squared. I thought I had enough space. It's a little tight. Again, x squared minus 2xy plus y squared. The third rule that we're going to need to use it from the right to the left. So we need to be less Pavlovian with how we look at things. And the last thing we need to look at is I want to know how long this segment is. How long is this? Well, if the entire thing is g, and the two smaller things, which is h and I don't know, and I assume that I know h, and I assume that I know g, that means that the length of this guy will be the full length minus the other segment. Okay? So we're going to need these tools in order to create the law of sines. Now back to the side angle side pattern. We know the lengths of C and B as well as theta, which is an angle measurement. We do not know the length A, which is what we want to find. So we're going through all of this so we can find this third side length. Okay? Alright, so we can make a segment from angle B to the opposite side so the segment is perpendicular. By doing this, we've created right triangles, and I hope you remember the previous section, but what we did here is we already figured out how this value, right? So this value is actually C times cosine of theta. And we found this length. It's C times sine of theta. Right? So what we're going to do is we're going to be able to now find this length because it's this idea. All right? So that means that this length right here is the entire length, and you subtract away the smaller segment. So this length is going to be B minus cosine, B minus C times cosine of theta. So now we have a little right triangle where I know one leg, I know the other leg. I can use that to find the hypotenuse. So I use the Pythagorean theorem to find the hypotenuse length. So what I'm going to do is I'm going to erase all of this. I'm going to leave this so I can keep referencing the tools. But hopefully you understand how we got some lengths here. Now we're just going to do the Pythagorean theorem, and we will find the length of A. You know, maybe try it on your own and see if you find these ideas in there. So let me clean this up, and I'll be back. I'm back. So let's go ahead and actually calculate the length of A, right? So we have a little right triangle. We can now figure out the length of A using the Pythagorean theorem. So I'm going to set this up. We get C times sine of theta. We're going to square that, and we're going to add that to B minus C times cosine of theta. We're going to square that, and that's equal to A squared, which is our unknown. Now, remember, we just found this in the previous section of the video, and this as well. I left out the rest of the triangle so we could focus on the right triangle. It would get a little busy, I think is what the saying would be. So let's see here. C times sine of theta squared becomes C squared times sine of theta, or sine squared of theta, plus, I'm squaring the difference of terms, which is this. So I'm just going to follow this pattern. So it becomes plus, that's my x, so that becomes a b squared. This is my y, so I get minus 2 times b times c cosine of theta, minus 2 times b times c times cosine of theta. And then I take my last term and I square it, and it was a negative times a negative becomes a positive, so minus c cosine theta becomes plus c squared cosine squared of theta, and that's equal to a squared. All right, so I'm going to move some things around, and actually it might be a good idea to, I'll show you how I'm going to move it around. I'm going to move this guy over here, okay? And we are going to get now c squared times sine squared of theta plus c squared times cosine squared of theta minus 2bc cosine of theta and this is equal to a squared. All right, so now we've set this up where if I'm multiplying the same thing times two other things, I can pull that same thing out. So both of these guys are being multiplied by c squared. So I'm going to go that way and take out the c squared. And now I'm left with sine squared of theta plus cosine squared of theta. Well, guess what that's replaced by? That's replaced by a 1. So now we get c squared times 1, which is just c squared. And let's bring down the rest. Oh, I lost my b, didn't I? So there's a b squared in there somewhere. Let's just move that over here. We'll move it back in a second. Sorry about that. So now we have c squared plus b squared minus 2b times c times cosine of theta, and that's equal to a squared. Now the length of A is going to be the square root of c squared plus b squared minus 2bc cosine of theta. That's our length of A. So we can now calculate our length of A, or the third side, when we have a side angle side pattern. So let's write that down. I'm struggling with my writing today. So we can now calculate the third side length when we have a side angle side pattern. So I'd like to do an example of this, and then I'd like to quickly talk about what it means. So let me clean this up and we'll jump into our third goal. And again, remember we wanted to find the third side length, so we found a formula for that. So let me clean this up and I'll be back. I'm back for the last time, I promise. Let's go ahead and jump into our third goal, and that's to find the unknown side length using the law of sines, and then we're going to understand where this leads. So I don't think I made it very clear. This is the law of sines. Or law of cosines. Oh, let me try this again. I'm back for the last time, I promise. Let's go ahead and jump into our third goal, and that's to find the unknown side lengths using the law of cosines and understanding where this leads. So I don't think I made this very clear prior to this, but this is our law of cosines. Now there's three different versions of it. It depends on who you don't know. But if I were you, I would always rename the known angle as A, the adjacent sides as C and B, and my unknown side is A, and that way we only have to know one formula. All right. So let's go ahead and finish this problem. Let's find the length of A. So we know that here's an example where the measure of angle A is 40 degrees. Side length C is 9 units. Side length B is 12 units. We have a side angle side pattern, so we can use the law of cosines. And let me get my calculator machine to use my law of cosines. But I would like to see you guys plug in. So A is equal to, let's see here, 9 squared plus 12 squared minus 2 times 9 times 12, or 12 times 9 times cosine of 40 degrees. So let's go ahead and calculate this. Let's go ahead and calculate this. All right, turn it on. There you go. You're awake. So I want the square root of 9 squared plus 12 squared minus 2 times 9 times 12 times cosine of 40, and that's going to equal 7.71. So A is roughly 7.1. All right, now that we know the third side length, we technically have the angle side pattern, right? And I'm talking about where this leads to now. The law of cosines will get us to the angle side pattern. Okay? And so now we can use a flowchart to determine how many triangles we can solve and proceed to solve them using the law of sines. So the law of cosines gets us back to the law of sines. All right? So hopefully this makes sense to you guys. You're going to just be maybe finding links, maybe then solving the triangles. I don't know. I'll figure out your homework assignment when I write it. But again, let's see. Should I go over there? Yeah. So we created the law of cosines by making right triangles using the Pythagorean Theorem to find the unknown length. And we got a law of cosines from that. So again, I hope everyone is doing all right out there. Have a good day, everybody. Bye-bye.